Newton's form of calculus more powerful than Leibniz? Those were the two fathers of calculus. Leibniz didn't really employ power series at all. So there were things that Leibniz could not integrate at all that Newton could. And of course, I mean, that's kind of like having extra gears, you know, if you're in a race. It's just he could go places that Leibniz couldn't go.
Although Leibniz might get notation.
Yeah, his notation's nice. So again, if I wanted, forget that problem now. If I went back and just gave you this, right? That's a definite integral. That would be the area under that curve, wouldn't it? That'd be the area under that curve between 0 and 1. Then all you have to do to figure this out is take the antiderivative of this. Help me out here. I believe it was 1/4 x to the 4th minus 3 factorial times 10 x to the 10th plus 1 over 5 factorial 16 x to the 16th plus dot, 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 right? And I would evaluate it at 0 and 1, right? Plugging in 0 would wipe everything out, so that won't matter. Plugging 1 in, well, this would just be 1/4 minus
1 over 3 factorial.
6, 10, 60 plus, whatever that is, minus 7 factorial, what are we adding? 6 to that, so 20, 22, something like that, right? And if we start putting that in our calculator and adding those up, we're going to start to converge to the true area. The further out we go, the closer our answer is. Cool? All right. Let's try this one. Find the Maclaurin for f of x equals e to the x sine x. I'm pretty excited. We're going to get into chapter 8.
You're so.
That's not what I meant. We're going to get into chapter 9 is what I said.
It's like I thought we were, but.
We're going to do that next week,
Where's the test actually stop?
wherever we stop.
Should we like stop and not?
Can we just stop?
Just stop right
Please
there.
stop. Please.
Stop.
I'm just like, what if we like all walk out?
do a protest.
How about how about whiskey? I know you're running out of your whiskey bags. So.
I'm good.
What if there was just a?
Come on, let's go. Come on, let's go. Find the Maclaurin for this.
So take what we did for E of x, take what we did for sine of x.
Yeah, so there, if you start approaching this the way we did before, which was just to start like taking derivatives and find a pattern to get the formula, just think about what those derivatives are going to start to look like. Pretty bad, right? Yes? So instead, why don't we ask ourselves this question? I know the power series for this, right? I know the power series for this. Can you multiply two power series together? Yes. How? That's what this is about, okay? So we're moving on to the last topic in this section, which is how do you multiply and divide power series? With me? All right, so what is e to the x written as its Maclaurin series? Sum n equals 0 to infinity, 1 over n factorial. But that's the formula we got at the end, right? That's e to the x, Maclaurin. Okay, times, now, sine series, which is this one, alternating, 2n plus 1 factorial x to the 2n plus 1. Now, we unfortunately cannot just put these two together. Like take that and multiply times that and be done. It does not work that way.
It'd be nice though, right?
It would be really nice, but then it would be a lot easier to do this, right? Okay, so here's how we're going to do this. This is the approach, okay? I'm going to actually write out the first few terms of this one. Okay, so that's equal to, all right, in parentheses, start writing this out. It should be 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus 1 over 4 factorial x to the 4th plus, that should be good. Notice on 2, I didn't write factorial. Y'all understand it's there? And on 1 out here, I didn't write it either. Okay. Plus dot, 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 and it never stops, right? It just keeps going forever. But whatever that is, I need to multiply that times the expansion of this one, which is x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th plus dot, dot, dot. Yeah? Now, do we remember how to multiply?
Yeah.
Do you remember FOIL?
No.
Do you remember FOIL? Right?
Expansion.
It's expansion, right? So how would we expand this infinite polynomial with this other infinite polynomial? Following what we've learned in the past, take this first one, times it by this, then this, then this. So really when I do 1 times this whole thing, I just get this whole thing, right? Okay, so that's what I'm going to do. So I'm going to write all this, x, and now watch what I do here. Well, yeah, I'm gonna leave a space. Watch, you'll see why I leave a space in a second. It's not going to take that long because we're going to be done with it pretty quick here. X to the 5th minus 1 over 7 factorial. An infinite number of pages, actually. And then plus dot, dot, dot. Okay. Do you agree that that's the first, the 1 being multiplied through? Yes? Yes? I left spaces for evens. All right? The next thing we would do is multiply x through to all of these, right? Yes. When I do x times x, I get x squared, right? Yes. And I'm going to add it to this in here, yes? So I could add it right out here. But what I'm going to do is start creating like a couple of rows, and then I'm going to add down the rows. So I'm going to put that x squared, right? Yes. That would be between these two, and I'm going to put it right below it, x squared right here. Just remember, what I'm going to do when I'm done is add straight down, okay?
Would you have the x because of the 1?
What? I already did the 1 through here.
Yeah. No,
1 through the x.
Yeah, when you FOIL, you still have to do the 1.
No, I did the 1 multiplied through all of those, and it gave me the first row. Now I'm going to do the x through all those. So the x to here is x squared. X to this one becomes what? Minus 1 over 3 factorial x to the 4th. And I'm going to put that right here. Minus, right? Minus 1 over 3 factorial x to the 4th. It's going to be something. We'll see after we do a couple of these.
Well, we knew the powers are going to be 1, 2, 3, 4, 5, 6, 7.
What's the next one? X times this one? So plus 1 over 5 factorial x to the 6th. Plus 1 over 5 factorial x to the 6th, right? You all following this? Yeah. Let's do one more. Times this. Minus 1 over 7 factorial x to the 8th, and it keeps going. Dot, 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 dot. Yes? Yes. Okay. So I've done the first two. Now I move on to the next one. What's 1/2 x squared times x? 1/2 x cubed. That's going to go in my x cubed column. Right? 1/2 x cubed. I'm out of room. And what's next? This times this piece right here.
6 factorial or
Yeah, let's do the power first. X squared and x cubed would be x to the fifth. So I'm going to be in this column, right? The coefficient is 1/2 times 1 over 3 factorial. I'm just going to write that down. 1/2 times 1 over 3 factorial, x to the fifth. Was it plus or minus?
minus?
It was minus, so I need a minus on that. Let's try one more. 1/2 x squared times this one. So 1/2 times 1 over 5 factorial. So plus 1/2 times 1 over 5 factorial, x to the 7th, right? Agreed?
Yes.
And I could keep going, but I'm not. All right, so I'm done here. What would happen on the next move? Here to here would be 1 over 3 factorial x to the 4th plus
Making a nice little triangle.
plus 1 over 3 factorial x to the 4th.
Yes.
And then this one times this one.
There's just like 1, 2,
Can we
3.
is there a way to multiply the factorials? Like you said,
Oh yeah, we can put these together. I'm just leaving them there so you can see like where they came from initially.
so if we did it, do we add or multiply it? Like if you
It's all
had
add.
3 factorial.
We'll do it. We'll do it. We'll do it. We'll do it. Okay, so here times this one is what? Negative. What's the power going to be? X to the 6th, so I'm over here, right? We're going to have negative, isn't it 1 over 3 factorial times 1 over 3 factorial again?
Yes.
X to the 6th.
We can go far away.
And we could keep going, right? So
I see a triangle coming.
what's often asked on something like this, or what's often, when you're presented something like this, what they often say is, give me the first 4 terms of this power series. So I asked you for the Maclaurin series for this, right? Normally they'll say, give me the first like 4 terms or 5 terms. Because this will become a disaster if you have to do the whole thing, right? And remember, this is all about, how accurate, how precise do you want to be? The further you go out in this multiplication, the more accurate you'll be, but sometimes we don't need that accuracy, right? The first 4, the first 8, the first 10 are good enough, right? So now what I'm going to do is start to put these together. Let's see what would happen if I go to the next one, right? I would have this 1 over 4 factorial x to the 4th times x, right? And then that would go into my 5th category here. And if I want the first 4 terms, 1, 2, 3, 4, this should be okay, right? What I'm saying is that from here on out, the powers on x are bigger than 4 or higher, aren't they?
Yeah.
No matter what. So they're not going to impact anything I do from this point on is going to have 0 impact on that stuff. Won't it? You understand that?
Yeah.
Okay. So let's put these columns together. I'm going to erase this. This will be equal to, all right, x, right? Yay, x. And then this, plus x squared. And then these two together, right? Yes? So they both have x cubed. And so I just put the coefficients together. Isn't it this and this together, added together? So like if you had 5x cubed plus 8x cubed, you would add the 5 and 8 together. So we're just going to add these two together. So how about I put negative 1 over 3 factorial plus a half. See, that's just some new coefficient, isn't it?
Yes.
And then the last one, they cancel, don't they?
Yeah.
That means that I wouldn't have the first 4 terms, would I? I only have the first 3. Because this one canceled?
We'll go 1 over.
I don't want to.
That's fine. We're just going to get the first 3, all right?
Since it canceled, couldn't we just move to the next term and that would be our 4th term?
Say again?
So like the x to the 4th's canceled. So if
Yes.
we wanted the first 4 terms, since we've already done the work, then we just move to the next one.
But there was another one that we didn't put down here. There was another, when we had got to the next multiplication, it was the 4th power, and it was going to hit x, And I didn't include that one.
It would have been 1/4 factorial
X
x.
to the fifth.
Yeah, I trust you. I'm just going to let it be.
Okay.
Okay, so plus dot, dot, dot. Now, this is a number, isn't it? This right here, this is really negative 1/6 plus a half. And that's really what?
Wait, that's a factorial.
Yeah, but I did the factorial. 3 times 2 times 1.
I got you.
So 2, negative 2, 6, 4, 12, 1/3?
Yeah, sounds about right.
1/3?
Yeah, 1/2 minus a sixth.
Yeah.
Yes, so 1/3 x cubed. You follow? Something seems off on this. What did we do? Sine
E to the x sine.
1 over x, so x squared. Well, let's do this. Something seems off, but I don't see what it was.
It seemed right what you
E exponential of x
did. I mean the math.
times sine x. So I'm just going to type in Wolfram alpha exponential x times sine x and just see what it does. Did it do anything? Oh, come on. This thing's so slow. There we go. There it is. Oh, I'm covering it up. Sorry.
No, we're doing it. We got it.
That's it. Okay, we got it. Something seemed off, but it's all right. So here's the series expansion. Now they did the first 5 because they is a computer.
It's a computer.
And so they got x squared, and then x cubed over 3, right? And notice we had plus, plus, and plus, right? The next one would have turned out to be minus. So this isn't even like an alternating. It doesn't have the perfect like alternating series pattern, like plus, minus, plus, plus, but there is a series for it, all right? So now if you wanted to integrate this, right? If you wanted to integrate this, then you could integrate that instead. Make sense? Now we could integrate that. Do y'all remember how to integrate this? Like if I asked you to integrate this? No, this right here, old school.
Yeah.
It's integration by parts, and it appears again on the other side, and you have to bring it over, and
Yeah.
yeah, that's that problem.
Like the integral is
All right, how about this? How about the, let's find the series, find, I didn't hear you, what?
Why is the fifth term 0 times?
Does that mean like all the coefficients?
Oh, no, it's giving you, that's the order that it's stopping at. It's stopping at the order of the 6th degree polynomial.
Oh, that's
So
not
it's,
zero.
that's order.
So it's not like it stops there.
Look, big O notation is what that is. Big O. I don't know. Any computer science people, y'all know what I'm talking about when I say big O? No? Computer science?
Like they're not known for naming their stuff.
No? Okay. Computer science, you'll know what big O is at some point. Big O. Getting this out of here. Big O. Okay, find the Maclaurin for f of x equals cosecant x. It's all right. I've been looking at it. I'm just going to slip on it and fall. Hurt myself.